Sir, I still can't see your screen, sir. It's black.
Okay, is it now visible? Tell me.
Yeah.
Okay. Okay. I'm starting with chapter coordinate geometry today. And in coordinate geometry, the first thing we need to understand is why do we actually need this coordinate geometry? What is the utility of coordinate geometry? When we try to understand the utility, the first thing is point. When we consider point in plane or space, we just figure out that point has no location. Point actually has no location, point has no dimension. That is why there is need of point to locate somewhere. And in this way, we have originated a special branch of mathematics that is known as coordinate geometry. Earlier, there was only geometry, and we were discussing only geometrical problems earlier. In geometry, there were many mathematicians involved, especially it originated from Egypt, then it developed there in Greek. There were many mathematicians who worked in geometry a lot. One of them is Euclid, you must be aware of this. There were another mathematician, Thales. There were one more mathematician, Pythagoras. You must have heard Pythagoras theorem. It is given by him only. And also Bodhayan, but we rarely heard the name Bodhayan because he is Indian. Indian don't take credit. They just discovered, they just work, they don't take credit. Pythagoras is disciple of this Thales, and there is Euclid geometry first developed, in which we make use of deductive reasoning. That means we first frame set of rules, and by using those rules we prove something. Thales has given us BPT, basic proportionality theorem, or Thales theorem, that tells about triangles and its ratio. When we just consider a line parallel to one of the side, how does it divide itself? Pythagoras theorem is used for right angle triangle, that suggests the hypotenuse, that is the longest side square, is sum of other two sides square, that is p square plus b square. You must be aware of all these things. And the main thing that we are going to consider today is point. We covered everything in geometry. Point was there a part of geometry, and obviously it is a part of geometry. But we couldn't define the point as a valid entity because point can't be expressed using any dimension. And that is why it is very much needed to locate a point properly. And from there, we just developed one more geometrical approach, and even it has been developed as one of the branch of mathematics, and we deal point in coordinate geometry. What we actually do here in coordinate geometry, we discuss a Cartesian plane here, and in
Yeah.
Cartesian plane that we discuss, we can also discuss any space. That means we can discuss a plane or we can discuss a space under coordinate geometry. Right now in our syllabus, we will confine ourselves up to plane only. That means two-dimensional geometry it is known as. In higher classes, we will be discussing points in space, line in space, and there we will discuss three-dimensional geometry as well. As we are discussing point and how to locate point, and that is why there is need of coordinate geometry, we should understand what we actually do to locate a point, to represent a point. To locate or to represent a point, we need relative approach. What is that relative approach? We use relative approach. Suppose you want to specify that where is your residence now. You will just put some landmark. What is it landmark? What is the nearby place? And in this way, you will locate your location, that you are residing right now. Similarly, in order to locate a point, we make use of relative approach, and this relative approach give rise to two reference lines. Here we will be using two reference lines, and those two reference lines are actually x-axis and y-axis. We will be using x-axis and y-axis, and these x-axis and y-axis will help to locate a point. X-axis is simply a horizontal line and y-axis is simply a vertical line, and they are actually going to be mutually perpendicular in a coordinate geometrical plane. In a Cartesian plane, we just consider them mutually perpendicular in same way as I have represented here. They are mutually perpendicular, they are making 90-degree. And this horizontal line is x-axis and this vertical line is known as y-axis.
Yeah.
These are two lines, x-axis and y-axis, as I have just indicated here. They are making 90-degree. Now, in a number line, if you remember, there is a center at middle, that is 0, and 0 at middle, and then we have positive values towards right and negative values towards left. The same thing is applied here. This is our 0 origin, you will say. The point is 0 here. It is origin. Then we have positive values towards right, and we have negative values towards left. And also remember that positive values upward and negative values downwards. In this way, we have coordinate system that look like our Cartesian plane. We can also call it Cartesian plane because it is represented as a plane right now. Here the plane is divided into 4 parts actually, and these 4 parts are first, second, third, and fourth quadrant respectively. These 4 parts in which these two reference lines has divided the plane are known as 4 quadrants, respectively known as first quadrant, second quadrant, third quadrant, and fourth quadrant. The point may be anywhere on the plane, maybe in first quadrant or second or third or fourth, and it can be located. It can be well specified that it is a particular point. All of the point, any point, randomly I can represent any point. Remember, all of them has a specific position. All of them has a specific location. And the same type of concept is also used to represent all location there in this world, there in the earth, there on the earth, and we use latitude and longitude for the same. It is for plane, it is for any plane, and here we make use of reference lines x-axis and y-axis. In x-axis, everywhere y is 0. None of the point is going to have any y value because you don't move towards upwards or downwards whenever you move in x-axis. That is why in x-axis we call y is equal to 0, and it is also known as equation of x-axis. Similarly, in y-axis we don't have movement towards left and right. That means we don't move in x-axis. That is why x is said to be 0 whenever we consider y-axis. If someone asks you to tell what is the equation of y-axis, you will tell that x is equal to 0 is the equation of y-axis. Similarly, if someone asks what is the equation of x-axis, you will tell that the equation of x-axis is y is equal to 0. Similarly, if a line is parallel to y-axis, what will be its equation is a question. If a line seems to be parallel to y-axis, and let's say you just know it passes through 2.5, you will call it x is equal to 2.5. It simply means in this particular line, whatever you consider your y may be 0, y may be 1, y may be 2, y may be anything else, but your x is going to be 2.5 only. That is why you call this line x is equal to 2.5. Similarly, if your line is parallel to y-axis, you got that? If your line is parallel to x-axis like this, then your equation is going to be y is equal to -3 if it passes through -3. Why do you say so? Because in such a condition, whatever x you consider, let's say your x is 0, let's say your x is 1, let's say your x is 2, whatever, let's say your x is -1, whatever your x is, y is going to be -3 only. That is why you call it y is equal to -3. Here I have told you four important things that I want you to remember. What are those four important things? The first thing is equation of x-axis. The second important thing that I have just explained here is equation of y-axis. Similarly, the third thing that I have presented here is equation of a line parallel to y-axis, and also equation of a line parallel to x-axis. These are different things that I have just explained, and I want you to tell me the first thing, equation of x-axis. Equation of x-axis.
So the equation of
Tell me the equation of x-axis.
okay, equation of x-axis, right? That
Yeah.
is y equals 0.
Exactly. Equation of x-axis is y is equal to 0.
Yeah, and I,
Yeah, I'm using different color. Equation of x-axis is y is equal to 0. What about equation of y-axis?
x equals 0.
Equation of y-axis is x is equal to 0. Equation of a line parallel to y-axis. Equation of a line parallel to y-axis. Here you can just observe. This is equation of line which is parallel to y-axis. You got x is equal to 2.5. You may get x is equal to any constant depending upon where does it passes. Where does it pass? If it passes through 2.5, you will call it x is equal to 2.5. That is why I'm just writing x is equal to k in generalized form. What about equation of a line parallel to x-axis? If it is parallel to x-axis, it must pass through any point on y-axis. That is why you will get y is equal to any constant. It may be y is equal to -3 or maybe y is equal to 2 if it passes somewhere at 2, exactly at 2. Okay, in this way, you need to understand these 4 points first before I tell anything else. Okay, first of all, I have just explained from where we have started this geometry and how does it come in this particular frame, in this particular form as well. And I have just explained that it has been developing from very ancient period and from Egypt and later on Greek, and now in this form it is. Earlier this point was a part of geometry, and today as well it is a part of geometry. Euclid has just defined the point that it is an entity that has no part. It has been defined by Euclid at that time, the ancient time. Right now we define point as an entity that has no dimension, but a fixed location, a specific location. Why do we say that it has fixed location? Because we have one more geometrical approach. We have one more geometrical approach, and that is one more branch of mathematics known as coordinate geometry, where we can specify and locate points. That is why we firmly say that point has exact location, point has exact position. For the same, we make use of reference lines, and those reference lines are horizontal x-axis and vertical y-axis. It is quite equivalent to the number system, and it starts with 0, and towards left it is negative, and towards right it is positive. Same with the y-axis, upward it is positive, downward it is negative. And the Cartesian plane actually look like this, where these lines are mutually perpendicular, make 90-degree, and here this point is origin, that also represent x-axis 0 and y-axis 0 as well. Towards left again we will take negative values, towards right positive values, upward positive and downward negative. And this entire plane has been actually divided into 4 parts, that are first quadrant, second quadrant, third quadrant, and fourth quadrant, that you can observe here as well. And here we came to know that on x-axis y value is always 0. That is why equation of x-axis is y is equal to 0. Similarly, y-axis has no x movement towards left and right movement. That is why we call x is equal to 0. For y-axis as a line, we will define the equation x is equal to 0. Similarly, if I consider any line parallel to y-axis, it will be generalized as x is equal to k. If my line is parallel to x-axis, it will be generalized as y is equal to k. Okay, so far I have explained up to this. Are you okay with this?
Yeah.
Now we will consider some other things like abscissa and ordinate. Abscissa and ordinate. I will be explaining these two terminology in detail.
Okay.
Abscissa, and one more terminology is ordinate.
Okay.
Okay. The first thing is abscissa is also known as x coordinate. And
Okay.
a point, first I will tell you, a point is represented using, a point has a specific position, and that specific position is known as its coordinate. A point has a specific position, that is its coordinate. And the coordinate of point actually consists of two things, and those two things are abscissa and ordinate. Got it?
Yeah.
What are these abscissa and ordinate? These are actually the specific position of a point. We make use of abscissa, that is x-axis, and we make use of ordinate, that is not x-axis, actually x coordinate, and y coordinate. I'm writing CO2 for coordinate to represent the specific position of a point. And we represent like this. Let's say point is P. We use this bracket, and we use order pair symbol. This is a comma. Here we have x coordinate. Here we have y coordinate. That means first value of this order pair is known as x coordinate, and second value is known as y coordinate. The first thing you note here that abscissa is x coordinate and ordinate is y coordinate. I have just explained what is x coordinate and y coordinate. I will later on tell with some diagram as well. Okay, no problem at all. I'm drawing diagram as well so that I can explain it in much detail. The diagram is here in front of you as well. Okay, first I will tell you in this diagram, then I will explain with one more diagram later. what actually happened here is how much we move towards x. Let's say I have moved towards x up to 2, then I will call x coordinate as 2. If I also move after moving 2 unit towards x parallel to y as 3 unit, then I will call it that I have moved up to 3 unit parallel to y. If I start moving from origin and move 2 unit towards right of x and 3 unit towards just above parallel to y, I will name this location as 2, 3. And this location is a point that represent the exact movement, exact position. Now you are considering 2 unit movement towards right on x-axis and 3 unit movement towards or just upwards parallel to y-axis. By observing this 2, 3, you can just tell that right on how much right? 2 unit right on x-axis and 3 unit upward parallel to y-axis. This idea can be drawn if you just see the point 2, 3. That is why we call this, that is why we say this, it is a specific exact position that we can now specify for a point. That is why we are well sure that point has a fixed position. Earlier it was not well sure. Euclid, at time of Euclid has just said that point has no part. This was the definition of Euclid. They have not explained anything about their position. But right now we have one more geometry as a part of our mathematical branch, coordinate geometry, and now we are well sure about point. We have exact position for a point, and it is possible due to this relative approach that we apply here using reference lines x-axis and y-axis that I have just specified and presented here. Now the second point that we can just put here is how we move on x-axis. That means distance traveled along x-axis is also known as x-coordinate. Whatever distance you traveled along x-axis is x-coordinate. Here we have traveled a distance 2 unit along x-axis. That's why this 2 is your x-coordinate. Got it? Similarly, for the ordinate you will write distance traveled along y-axis or maybe parallel to y-axis. Here you have traveled, yeah, here as well you may consider parallel to x-axis. Here you have moved a distance of 3 unit from this point parallel to y-axis. That is why the y-coordinate is 3 over here. And in this way we specify coordinate using abscissa and ordinate. Got this? Is it clear now what is abscissa? One more thing can be shown here, and I will show, just see here. Let's say I'm here at point P. Let's say I'm here at point P and now I want to work for this point. What can I observe? What can we observe? If I'm drawing a perpendicular from this point on y-axis, it is going to give you how much distance? You will say that it is going to give you 2 units. And if you are drawing a perpendicular on x-axis, how much distance will it give? It will give 3 units. That means if you are drawing perpendicular on y, it will give you x coordinate. And if you are drawing perpendicular on x-axis, it will give you y coordinate. That is why one more definition is there, that is like this. What will you call it? You will call it perpendicular. I'm writing a symbol. Perpendicular distance of the point. That means I need to go up to point that first. Perpendicular distance of the point from where? From y-axis, just opposite. And here perpendicular distance of the point from x-axis. I want you to observe it once again. I'm using highlighter for you. Let's say you are drawing a perpendicular from this point. Yeah, so see this here. If you are drawing a perpendicular from this point P on your y-axis, you will get 2 units. That is your x coordinate. Similarly, if you are drawing perpendicular from this point on your x-axis, this distance that you will be obtaining here is 3 units. That means if you are drawing perpendicular on x, you will get y coordinate. Got it or not?
Yeah.
All right. Are you okay up to this or these points that I have just covered? Similarly, I want you to understand one more thing. If a point is lying on x-axis, whenever a point lie on x-axis, its x coordinate is something, but y coordinate is 0. Similarly, if point lies on y-axis, it has only ordinate, but its x coordinate is 0. That means abscissa is 0. It has only ordinate. But if my point lie on any of the quadrant rather than x-axis and y-axis, then it has both coordinate. Here both are positive, that is first quadrant. X is also positive, y is also positive. In case of second quadrant, you will first move how much, some distance towards x-axis, but towards left. If you are moving towards left, you will consider negative sign. Here you moved minus x, then moved plus y. For the third quadrant, you will move minus x and minus y, because this side you will be taking negative values. That is minus x minus y is the sign for third quadrant. Similarly, for the fourth quadrant, you will be moving towards right from origin and to downwards from that point, and that is why this is going to be plus minus. And in this way, I want you to note it down and
Yeah.
note down their
Quadrant 1, 2, 3.
sign as well. Yeah,
Okay.
sign as well. It's important for you. For first quadrant, the sign is plus plus. For the second quadrant, both are minus plus respectively. For third one, we have both negative, and for the fourth one, x is going to be positive but y is negative. I'm representing it as they actually look like. In this bracket, there is a comma because these are two coordinate, x coordinate and y coordinate. That means by just observing the coordinate, we can answer that whether it is in x quadrant or it is in y it is in first quadrant or it is in second quadrant or it is in third quadrant or it is in fourth quadrant or it is in on x-axis or it is in on y-axis. If it is on x-axis, it look like this. If point is on y-axis, it look like this. That is why it is possible for us to explain about point. Okay, I will ask some question based on all these things that I have explained so far. I will be asking some question now. Here, the question number first for you. 4 comma minus 2. Tell me the quadrant of this. And also represent this. First tell me quadrant, then I will show you how to represent it.
Okay, what is it? 4, comma, minus
This is
2,
0.
right?
Now it is going to be,
Yeah,
yeah,
if
tell
it's
me.
4, yeah, if it's 4, comma, minus 2, that's quadrant 4. Plus
Exactly.
minus is 4.
You have to move 4 unit here on x-axis, then 2 unit downwards. Then only you will be able to reach here 4 comma minus 2. That is fourth quadrant, and it can be located like this. I have located here. Let's say it is P. I will call it P. Point is located using capital letter. Remember that. All right. Okay. Now the second question. First, tell me about this, and then also tell me about its location.
Okay, minus 3, 4, right? Minus
Yeah,
positive, that is quadrant 2, and that, yeah. So x
exactly.
is
Second
minus,
quadrant is its location. And how will we locate? Minus 3 unit, we will move towards left, and then we will move towards 4 unit parallel to y-axis just upward. And in this way, we will get minus 3 comma 4. Let's say the point is capital Q, and here you can show like this. Similarly, I have one more question for you. I want you to locate a point R which is 4 comma 5. Can you locate it, and can you tell me where does it lie?
okay, 4, 5, that's plus plus quadrants, that is 1.
Exactly, it lies on first quadrant. It's exactly correct. And first we will move towards right side of x-axis, and we will be moving how much towards right? We will be moving 4 unit towards right up to this. Then we will be moving 5 unit just parallel to y-axis, and here we have point 4 comma y, that is r. Okay, one more question. I want you to tell me, where do you represent point S, that is minus 2 comma minus 2? Where will you represent this?
Oh, minus 2, that's quadrant 3.
Exactly, both are negative. That means it is of third quadrant point. And can you tell me where does it actually lie? How can you represent this?
Oh, yeah, so the x will be negative 2, so on the left you move to negative 2, and down you move to negative 2.
Exactly. First, we will move towards left from origin, 2 unit, minus 2 unit, it will be called. And then we will move downward the 2 unit only. And here I have to move like this, because this one is 2, minus 2. And that is why the point S, let's say, will be known as minus 2 comma minus 2. That is why we now firmly say that point has exact location, because coordinate geometry, coordinate system, this Cartesian plane help us to locate point with a specific location. Now I want you to answer one more thing. Can you tell me where can you locate the point 7 comma 0?
Okay, so first on the right
Where
you
will you
move
locate
the
it?
7th. So that is on the
Yeah,
first
we have
quadrant.
to move 7 unit rightwards.
Yeah, that's all you have to do because
Here
y
it
is
is,
0.
and we will name it 7 comma 0, isn't it?
Yeah.
This is on x-axis, isn't it? The
Yeah.
point is on x-axis. Okay, can you tell me, where do we locate a point named as, let's say it is T, but I want you to locate point X, and it is named as minus 3 comma 0 comma minus 3.
Okay, so since the x-axis is 0, yeah, that'll stay there. So we move down to minus 3 on the y-axis.
we will move on y-axis and it will be 0 comma minus 3 and your x point, and it is on y-axis, isn't it? In this way, now is it okay for you to represent a point on x-axis, on y-axis, on any of the quadrant? Now can you identify all of these quadrants? Now can you just identify what is abscissa, what is ordinate, what is these differences? I think you are okay up to all these things. And if you are okay up to this, we can now go towards one more concept that is known as distance formula. There is two things that we can deal here related to coordinate geometry, and these two things are, the first thing is distance formula that help us to figure out distance between any 2 points lying on the plane, and another thing is section formula that help us to figure out the sectional point and its coordinate if a line is intersected or cut using another point or another line. I will be telling you these two things now here. In both of the cases, it is quite known to us that we are dealing with a coordinate geometry, Cartesian plane, that must be like this. X-axis will be there, y-axis will be there, they will be mutually intersected here. This is origin that we will calling, and here we have positive values, here we have negative values, here we have again positive values, downwards we have negative values. The same thing is applicable for any other section formula as well. Whatever it is, either it is distance formula we will be using or section formula we will be using, we are actually working with the coordinate geometry. That is why the same type of x-axis, y-axis and leftwards, rightwards movement will be done, and you need to understand the sign to be considered like this, and I have just shown here. What is the difference in both? The difference is there, you should say, where we actually use them. In case of distance formula, we use them if we want the distance between any 2 points. Let's say there are 2 points lying on the plane like this. The point A having coordinate x1 by 1 and point B having coordinate x2 by 2, and we want distance between them. I'm just telling you that if you are drawing a perpendicular here like this, perpendicular here like this, you will call this as y2, you will call this as y1. Okay, are you okay with this? You will call this distance as x1 and you will call this entire distance as x2. I think you must be okay. Okay. Now, another thing that I'm doing here is I'm drawing one more perpendicular, and I'm just denoting it as C. Can you tell me what is AC? If this up to this and this, you are having x2 distance, and this much is x1, you can tell that x2 minus x1 is going to be this distance, and that is also AC. Similarly, from this point on x-axis to B, you are having y2. And this much is y1. That means if you want this distance BC, you have to subtract y2 and y1. If you are having those distances as y2 minus y1, you can just tell me AB is nothing but hypotenuse, and that is why it will be square root of AC square plus BC square. Is it okay for you? Because we know the hypotenuse square is equal to sum of a square of other two sides. That's why if you take a square root both sides, you will be able to say like this. And from here only we will be able to develop a distance formula from today onward, because x2 minus x1 is your AC and y2 minus y1 is your BC. That is why this is our distance formula that I want you to remember from today onward. Under root of x2 minus x1 square plus y2 minus y1 square. And by using this distance formula, we can find out the distance so easily. Let's say this point is our 1, 1 that you can see here. And let's say the point, second point is your, I'm just telling it, 6, 5, let's say, and I want distance between these two. You will be using same formula. I'm just telling you. This question may be asked distance between 1 1 and 6 5. How will you figure out this question? How will you figure out this distance? You will call the 1 as x1, y1 here, x2 this one, y2 this one, and you will use this formula to answer this. Under root of x2 minus x1 square plus square root of y2 minus y1 square. Here you will be substituting these values: 6 minus 1 whole square plus 5 minus 1 whole square. Again, you have to just simplify it: 5 square plus 4 square. Further, you will be simplifying this as 25 plus 16, and you can just leave your answer in square root as 41. Root 41 unit is your distance that you obtained using distance formula, and that is why we call and we tell it as a distance between any 2 points on the plane. By using this, you can figure out distance between any 2 points on the plane. This is its utility. This is its use. Then what is your section formula? Here in section formula, whenever we consider section formula, we have this AB here as well. But what extra we have is either we have another point C here, or we have a line that is going to cut it somewhere at C. This line is going to intersect this AB, and that is why my AB will be divided. My AB will be divided in a definite proportion. In a given ratio, it will be divided, and I'm right now telling you how will it be divided. Let's say it has been divided as the ratio of M is to N. Here as well, the point A is x1 by 1, B is x2 by 2, and this point C has divided it in the ratio M is to 1. M is to N. And the section formula, what is its utility? It will help you to specify the coordinate of this sectional point. This is the utility of section formula. I'm not going to tell you the proof, but I want you to remember this section formula. It's so easy to remember. You will consider M and you will multiply it with x2, and then you will consider N and you will multiply it with x1, and you will sum this and you will divide by these two, sum of these two ratio, in order to find out this x coordinate. Similarly, in order to find out the y coordinate, you will do the same approach. M and y2 will be multiplied, and similarly N and y1 will be multiplied together, and you have to divide it with M plus N. In this way, you will be able to obtain these x and y, that is coordinate of the sectional point. This is the utility of section formula. In section formula, one more case may arise when we are just intersecting it at middle point itself. How it came that we are intersecting like this? Let's say I have the diametric end as 4 7, and let's say 10 11, and now we want the coordinate of this center. In such a cases, we call this section formula as midpoint section formula, because here the sectional ratio is 1:1. That means M become 1 and N become 1. And if you substitute M equal to 1 and N equal to 1 in above formula that you can just observe here, in these two formula, if you are substituting M and N equal to 1, you will get midpoint section formula.
Yeah.
In here, if I'm substituting M1 and 1, it will be x1 plus x2 and divided by 2. I'm writing here. That means the sectional coordinate x and y can be just explained here x is x1 plus x2 over 2, and y is nothing but y1 plus y2 over 2. In this way, we can explain the midpoint section. Here, if I ask this question and I want you to answer the coordinate of center, can you tell me answer?
Yeah. So
Yeah, exactly, you can tell, because the x coordinate and y coordinate can be answered using midpoint section formula. X1 is 4, x2 is 10, over 2, we have to add 4 and 10, then 7 is coming out to be our x coordinate. Similarly, y coordinate 7 plus 11 over 2, that is coming out to be 18 over 2, that is coming out to be 9. That means this O has coordinate 7, 9. In this way, we may be asked to use midpoint section formula, or we may be asked to use section formula directly. Okay, we will mix question based on these two later on, you don't worry. Similarly, one more thing may be there, you using this. If I'm asking you to find distance from origin only, if I ask you to figure out any distance from origin only, what will you do? If I ask you to find out any distance, yeah, from this origin, this is my x-axis, this is my y-axis, this is our origin. If I want you to find out distance of point A, let's say 5 4 from origin, now I want you to just develop this as another formula, because here what is special is you are just substituting your x1 and y1 as 0 0, because origin is 0, and that is why our formula will be what? X2 square, because x1 is 0, that is why it will be x2 square plus y2 square. And for this question, let's say this is a third question, if I want you to answer OA, you will call it 5 square plus 4 square under root, that is under root 29 unit. 25 plus 16, no, it's not 29, it's 25 plus 16 actually, and 25 plus 16 we have earlier solved here itself. Yeah, it's root 41 unit. Is it okay for you that if you want distance from origin, we can directly use this formula as well? I'm just generalizing it as root x square plus root y square. It can also be used if you want the distance from origin. Okay, I have helped you to solve many, not many, but fewer questions that will help you to clear the concept of all this topic. I have almost covered all of the topic, all of the concept related with this topic. In next class, we will be solving more concept based on collinearity, because there are fewer applications of distance formula. Like distance formula can be used to use distance, or just apply the distance, calculate the distance. These can be known as application of distance formula, where we actually use this distance formula, where we actually apply distance formula. We can apply distance formula to figure out distance directly. We can apply distance formula to figure out whether points given are collinear or not. We can also use distance formula to figure out whether my triangle is equilateral or isosceles or scalene or right angle triangle. We can also use distance formula to figure out whether my quadrilateral is parallelogram or rectangle or square or rhombus. When my quadrilateral is parallelogram, we have opposite sides equal, but diagonals are not equal. In case of rectangle, the opposite sides are equal and diagonals are also equal. Similarly, if you want to distinguish between square and rhombus, you should understand that in case of square and rhombus, in both cases, you will get all the sides equal. But in case of a square, the diagonals are also equal. But in rhombus, you will not get diagonals equal. In this way, you should also know the properties of quadrilateral so that you can use distance formula and also apply and also apply the properties of quadrilaterals or triangles and tell whether it is particular quadrilateral or triangle. Similarly, you can also relate some relations using distance formula. Here in case of section formula as well, we can apply section formula to find out sectional point. We can apply this section formula to figure out ratio if sectional point is known. Even the sectional formula help you to figure out collinearity. But basically, we will be using section formula to find out sectional point and to find out ratio if sectional point is given. In next class, we will be solving many questions based on this. I'm ending up the session for